Internet Model or TCP/IP Protocol Suite. The Internet Model or TCP/IP model is the set of protocols used to communicate over the Internet. TCP/IP was developed by the Department of Defense Model. It is described on RFC 1122. Internet Model or TCP/IP model is divided into 4 layers: application layer, transport layer, internet layer, and link layer. The physical layer is openly not defined but assumed to exist. 5-layer Internet Model or TCP/IP Protocol Suite is a modified version of the Internet Protocol Suite or TCP/IP model. The physical layer is added to this model. The application layer provides the service for the user. The protocol divides into 2 categories: user protocol and support protocol. User protocol provides service directly to the user. For example, FTP for file transfer, SMTP for email service, www for internet surfing, and Telnet for remote login. The support protocol used for system function. For example, DNS for IP to host name mapping, and SNMP for management. Transport layer is responsible for end-to-end communication of the entire data. It accepts the data and adds the source and destination port number as a header. This is a software port. Each application layer protocol has a unique port number for identification. On receiving end, check the port number and deliver it to the specific application. Referring to the diagram, this is described as how port is added with data. Suppose in the source end, the user wants to communicate via email through HTTP. The transport layer received an HTTP request. The port number of HTTP is 80 and will assign on the source port number header, and the destination port will be 25. At receiving end transport layer, verify the destination port number, and here is 25. Port number 25 is allocated for SMTP. So, data has delivery based on the destination port to the application layer. Please note Internet Assigned Numbers Authority, IANA, is responsible to assign a port number. We will discuss it at a later stage. Transport layer help to control the connection. It uses 2 methodologies to control the connection: connectionless and connection-oriented. In connectionless, sending the data best effort basis. There is no acknowledgement or error checking. UDP is used for this purpose. Examples of connectionless connections are video streaming, online games, and VoIP call. Connection-oriented help to provide delivery acknowledgement, error checking, and recovery procedure. This is reliable communication. It cuts the data into small pieces called segmentation and sequence number assigned against each segment. TCP uses this purpose. TCP is responsible to control the flow of data. The transport layer adds the network protocol number so that the lower layer can identify the upper layer protocol. The protocol number of TCP is 6 and for UDP, it is 17. Internet layer helps to carry data from source to destination. For that purpose, we are using IP or Internet Protocol. The IP, Internet Protocol, is a connectionless datagram that is used for internetworking. Since this is connectionless, there is no guarantee on end-to-end delivery, and not reliable. Transport Layer Protocol TCP is responsible for reliable service. Source and destination IP are added as a header to reach the destination. ICMP is a control protocol and part of IP. However, it uses IP to carry data end-to-end just like the transport layer. Considering the RFC 1122, ICMP is responsible for error reporting, first hop gateway redirection, and congestion reporting. IGMP is also an internet layer protocol that is used for multicasting in a group of hosts. The network protocol is added with data to identify the upper layer protocol. Data link layer responsible for communicating with the directly connected network. It is part of the local connections where hosts are attached. That means it is established the hop-to-hop communication. It helps for the physical addressing of the data. Source and destination MAC address or physical address added on the header. MAC table is created in this layer. In the sender end, a checksum is calculated. Similarly, it calculates at the receiver end. The frame will pass only if both checksums match. Otherwise, it is discarded. The checksum is added to the trailer. After adding the header and trailer, the packet was converted into the frame. Further, the frame is converted into a bit and sent to the physical layer. In physical layer, bit converted into an electrical signal and transmit through media. Refer to the diagram of how host A communicates with host B. In the sender end, header and trailed are added layer by layer, and the receiving end pop the header and trailer. Finally, it delivers the data to host B.